Two of the world's largest economies are placing fundamentally different bets on the exact same technology, and the outcome could decide who actually controls the future of artificial intelligence. China just committed roughly $295 billion to build a nationwide network of AI data centers, deliberately locking out Nvidia and betting everything on homegrown chips instead. Meanwhile, American technology. Giants are pouring even more money, over $700 billion in a single year, into infrastructure built almost entirely around Nvidia's hardware. One approach bets on state control and self-sufficiency. The other bets on private capital and the best chips money can buy. Both approaches carry genuine, well-reasoned strategic logic behind them, and both come with real risks that will only become fully visible once each strategy has had years to actually play out in practice. Today, we are breaking down both strategies in detail, examining the genuine strengths and real vulnerabilities hiding inside each approach, and trying to answer the question everyone in this industry is quietly asking right now: when these two radically different bets eventually collide, who actually comes out ahead? Stick around, because this story reveals far more about the future of global technology than any single headline number ever could on its own. Let's start with China's side of this story, because the scale of what Beijing is attempting here is genuinely enormous. According to reporting from Bloomberg, key government agencies, including China's National Development and Reform Commission, are drafting a blueprint to spend approximately 2 trillion yuan, or around $295 billion over the next 5 years, building an interconnected network of AI computing hubs spanning the entire country. State-owned enterprises, specifically China Mobile and China Telecom, are expected to operate the bulk of these data centers, ensuring they remain properly connected into one unified national network rather than existing as a patchwork of disconnected regional facilities. This is not simply about building more computing capacity. It is about building an entirely new category of national infrastructure, treated with the same strategic seriousness China has historically applied to its highway systems, its power grid, and its telecommunications backbone. That historical comparison is worth sitting with for a moment, because it reveals something important about how differently China approaches large-scale technology infrastructure compared to how these projects typically unfold in most Western economies. When China decided decades ago to build out its high-speed rail network, it did not simply wait for private companies to gradually identify profitable routes and build them incrementally over many years based purely on projected ridership demand. The government identified high-speed rail as a strategic national priority and directed massive, coordinated state investment toward building an extensive network relatively quickly, resulting in China now operating the largest high-speed rail system in the entire world, built in a fraction of the time it likely would have taken under a purely market-driven development model. Applying that exact same top-down, centrally coordinated playbook to AI data center infrastructure represents a deliberate strategic choice, one that trades some of the efficiency advantages a purely market-driven approach typically offers in exchange for the kind of rapid, coordinated national scale that has repeatedly proven effective for China across multiple previous major infrastructure build-outs throughout its recent economic history. The most consequential detail buried inside this plan, though, is not the dollar figure itself. It is the deliberate technology sourcing strategy sitting underneath it. Beijing's plan explicitly calls for relying on local suppliers, including telecommunications giant Huawei, for at least 80% of the technology going into these facilities, including the AI chips that actually do the computational heavy lifting. That threshold effectively squeezes Nvidia and AMD almost entirely out of what will become one of the largest coordinated AI infrastructure build-outs in human history. This is not a new or sudden shift either. Beijing introduced a requirement back in August of 2025, mandating that data centers source at least half their chips locally. By November of that same year, state-funded projects were barred from using foreign accelerators entirely, with construction projects that were less than 30% complete actually told to strip out Nvidia, AMD, and Intel hardware that had already been installed. This new nationwide plan simply takes that existing policy trajectory and applies it at a dramatically larger, decade-defining national scale. This kind of gradual, incremental policy escalation, starting with a partial local sourcing requirement before eventually moving toward near total exclusion of foreign hardware, follows a pattern that has become increasingly familiar across multiple different Chinese strategic industries over the past decade. Rather than announcing an abrupt, immediate ban that could create serious short-term operational disruption for companies still genuinely dependent on foreign technology, Beijing has repeatedly favored a more gradual, phased approach, allowing domestic industry time to actually build up sufficient production capacity and technical capability before fully cutting off the foreign alternatives that companies had previously relied upon. The same general pattern has played out in industries ranging from solar panel manufacturing to electric vehicle battery production to telecommunications, equipment where China first built substantial domestic capacity, while foreign competition still remained present in the market before gradually tightening restrictions. Once domestic alternatives had matured enough to genuinely fill the resulting gap. Applying that same well-established playbook to AI chips and data center infrastructure suggests Beijing views this specific technology transition with a similarly long-term, carefully sequenced strategic mindset, rather than treating it as a sudden reactive response to any single specific geopolitical event or immediate provocation. Understanding why China is willing to accept this kind of technological self-sufficiency, even at what appears to be a real short-term performance cost, requires appreciating just how seriously Beijing has come to view chip dependency as a genuine national security vulnerability. For years, American export controls have specifically targeted Nvidia's most advanced chips, preventing China from accessing the cutting-edge hardware needed to train the most sophisticated AI models. Washington has recently eased some of these restrictions, agreeing to allow Nvidia to sell its previous generation H200 chips to Chinese customers, representing components roughly one generation behind Nvidia's current top easing of restrictions. Actual shipments of those H200 chips have not yet begun, and industry observers have interpreted that hesitation as a genuinely telling signal. Beijing appears to be growing increasingly confident that domestically produced hardware can adequately fill the gap, rather than remaining dependent on American supply chains that could theoretically be tightened again at any moment based on shifting geopolitical circumstances entirely outside of China's own control. Huawei sits right at the center of this domestic chip strategy, and understanding the company's current trajectory helps clarify just how seriously this self-sufficiency push is actually being executed on the ground. Huawei shipped approximately 812,000 of its Ascend AI processors throughout 2025, and the company is projecting roughly $12 billion in AI processor revenue for 2026, representing a substantial increase of around 60% compared to the previous year. That trajectory could accelerate dramatically. Further, if Huawei and its domestic manufacturing partners can successfully scale up production to meet the demands of this new nationwide infrastructure mandate. There is a real complication here worth acknowledging honestly, though. Huawei's chip production depends heavily on SMIC, China's largest domestic semiconductor manufacturer, and SMIC continues to face significant supply constraints, particularly around advanced manufacturing capacity that remains meaningfully behind the cutting-edge production capabilities available to companies like Taiwan's TSMC, which manufactures Nvidia's most advanced chips. Independent analysis from organizations like the Council on Foreign Relations has documented a real measurable performance gap between Huawei's current generation chips and Nvidia's most advanced hardware, meaning China's self-sufficiency strategy currently involves a genuine trade-off between technological independence and raw computational performance per chip. It is worth understanding exactly why this specific performance gap exists, because it traces back to a genuinely difficult manufacturing challenge that money alone cannot immediately solve. Producing the most advanced AI chips requires extraordinarily precise manufacturing equipment, particularly specialized machining, as called extreme ultraviolet lithography systems, that are currently manufactured by only a small handful of companies worldwide. Most notably a Dutch company that has faced increasing pressure from Western governments to restrict exports of this exact equipment to Chinese manufacturers, without reliable access to this specific category of manufacturing equipment. Chinese chipmakers like SMIC have been forced to rely on older, less precise manufacturing techniques that inherently produce chips with somewhat lower transistor density and correspondingly lower raw computational performance, compared to what companies like TSMC can achieve using more advanced manufacturing equipment that remains largely unavailable to Chinese manufacturers under current export restrictions. Closing this specific manufacturing technology gap represents one of the most difficult, most capital-intensive challenges facing China's entire chip self-sufficiency strategy, since it cannot simply be solved through additional government spending alone, but instead requires genuine breakthrough innovation, an extraordinarily complex precision manufacturing technology that other countries have spent decades perfecting. This entire build-out also fits within a much broader Chinese infrastructure strategy that extends well beyond just data centers themselves. The plan connects directly to Beijing's larger Six Networks Infrastructure Initiative, and it builds on an earlier program known as Eastern Data, Western Computing, which has been strategically shifting computing capacity toward China's less densely populated western provinces, where land is considerably cheaper and electricity costs significantly less than in the country's crowded, expensive eastern coastal cities. This geographic strategy addresses a genuine practical constraint facing rapid data center expansion almost everywhere in the world, highest existing demand for AI computing power often have the least available land and the most constrained electrical grids, while areas with abundant cheap land and renewable energy potential frequently sit far away from where that computing demand actually originates. China's more centralized, government-coordinated planning approach allows Beijing to address this mismatch more directly than a purely market-driven system typically can, deliberately routing massive infrastructure investment toward regions specifically chosen for their favorable land and energy characteristics, rather than simply building wherever private companies happen to find it most immediately convenient. The same fundamental land and energy mismatch problem exists just as acutely within the United States, worth noting, where major American technology companies have increasingly had to negotiate directly with local utilities and even sign long-term power purchase agreements, including deals involving nuclear power plants, specifically to secure enough reliable electricity for their planned data center expansions in regions where existing grid capacity was never designed to handle this level of concentrated new demand. The key difference is that American companies have generally had to solve this challenge individually and independently, each negotiating its own separate deals with local utilities and grappling with its own separate local permitting and zoning challenges, often facing significant delays and local community pushback along the way. China's more centralized planning approach allows Beijing to address this same underlying challenge more systematically from the very beginning, deliberately routing infrastructure investment towards specific regions chosen in advance for their favorable characteristics, rather than leaving each individual company to independently discover and negotiate around these same underlying constraints, largely on its own, one project and one local jurisdiction at a time. The financing mechanism behind this build-out deserves honest scrutiny too, because it reveals something important about the risks embedded in China's overall approach. According to Bloomberg's reporting, China plans to fund this massive build-out primarily by issuing additional government debt. As of 2026, China's total government debt has already surpassed the country's entire annual economic output, according to figures from the International Monetary Fund. Committing an additional $295 billion in state-directed spending, potentially expanding toward $735 billion, once broader power grid integration costs get factored in, represents a genuinely significant additional debt burden for a government already operating with debt, levels exceeding its total economic output. This financing reality introduces a real element of economic risk into China's quantum computing bet that does not exist in quite the same way on the American side of this comparison, where the vast majority of AI infrastructure spending is coming from private companies deploying their own capital and shareholder-funded resources rather than government-issued debt. This distinction matters enormously when you consider how each system handles the genuine possibility of the underlying investment not paying off as expected. If American companies like Meta or Microsoft eventually discover that their enormous AI infrastructure investments are not generating sufficient financial returns, those specific companies bear the direct financial consequences themselves, potentially through reduced profits, lower stock prices, or difficult internal decisions about scaling back future spending plans. But the broader American economy and government finances remain largely insulated from that specific business outcome. If China's state-directed infrastructure investment similarly fails to generate the expected economic returns, the consequences flow much more directly into the government's own already strained fiscal position, potentially constraining Beijing's ability to respond to other economic challenges or fund other priorities precisely because so much national debt capacity has already been committed toward this single enormous infrastructure bet. This asymmetry in how investment risk gets distributed and absorbed represents one of the most fundamental, underappreciated differences between these two competing national strategies, one that becomes considerably more consequential if either country's underlying economic growth or AI demand projections end up falling meaningfully short of current expectations over the coming several years. Now let's turn to America's side of this comparison, because the sheer scale of private sector spending happening here genuinely dwarfs China's publicly announced figure, at least on paper. American technology giants, including Meta and Microsoft, have collectively earmarked more than $700 billion for AI investment in 2026 alone, a figure that exceeds China's entire 5-year public infrastructure commitment within a single calendar year. That comparison alone tells you something important about the fundamentally different nature of these two competing approaches. China's $295 billion figure represents coordinated, centrally planned government spending specifically directed at public infrastructure. America's spending, by contrast, represents the aggregate, largely uncoordinated decisions of individual private companies, each independently deciding to pour enormous sums into AI infrastructure because they believe doing so will generate a meaningful competitive advantage and eventual return on that investment. This distinction between Centrally coordinated state spending and decentralized private investment represents the single most important structural difference separating these two national strategies, and it carries real implications worth examining carefully. America's market-driven approach means individual companies retain enormous flexibility to adjust their strategies quickly based on changing technology, changing customer demand, or changing competitive pressure without needing to wait for a centralized government planning process to formally revise a 5-year infrastructure blueprint. If a particular chip architecture, a particular data center location, or a particular AI application turns out to be less commercially valuable than initially expected, individual American companies can pivot their spending relatively quickly, since they answer primarily to shareholders and market performance, rather than to a centrally coordinated national industrial strategy that inherently moves more slowly and carries more institutional inertia. Once large-scale commitments have already been formally announced and initiated, Nvidia's position at the absolute center of America's AI infrastructure strategy deserves particularly close examination, because it represents both the greatest strength and potentially the greatest vulnerability embedded within the entire American approach. Nvidia did not simply build faster chips than its competitors. The company built an entire software ecosystem around its hardware, centered on a programming platform called CUDA that has become deeply, almost irreplaceably embedded into how AI researchers and companies actually develop and train their models. This software ecosystem advantage means that switching away from Nvidia hardware involves considerably more friction than simply buying a different brand of chip with comparable raw computing specifications. Years of accumulated code, tooling, developer expertise, and institutional knowledge across the entire American AI industry have been built specifically around Nvidia's particular software and hardware ecosystem, creating what economists call meaningful switching costs that help explain why American companies have remained so heavily concentrated around a single hardware provider, rather than spreading their infrastructure bets more evenly across multiple competing chip manufacturers, the way a purely risk-averse investment strategy might otherwise suggest. To really understand the depth of this software ecosystem advantage, it helps to think about what actually happens when a research team or company decides to build and train a new AI model. That process involves an enormous amount of specialized software tooling, from the underlying mathematical libraries that handle the core computational operations, to the higher-level frameworks researchers use to actually design and train their models, to the specialized debugging and optimization tools engineers rely on to make sure everything runs efficiently at massive scale. Nvidia has spent well over a decade building, refining, and continuously improving this entire software stack specifically around its own hardware, creating an ecosystem so deeply embedded into standard AI development practice that switching to a fundamentally different hardware platform would require research teams to essentially relearn significant portions of their existing workflow, rebuild substantial amounts of specialized tooling, and accept a real risk of losing performance optimizations that have been carefully tuned specifically for Nvidia's particular hardware architecture over many years of accumulated refinement. This is precisely why competing chip manufacturers, even ones producing genuinely competitive raw hardware specifications, have struggled to meaningfully dent Nvidia's dominant market position, since the true competitive advantage increasingly lives as much in accumulated software maturity as it does in the underlying silicon itself. That concentration, however, represents a genuine structural risk sitting at the heart of America's entire approach, one that becomes increasingly consequential the longer it persists. When such an enormous share of an entire industry's critical infrastructure depends on essentially one dominant supplier, any disruption to that supplier, whether from a genuine technical failure, a serious cybersecurity incident, an unexpected supply chain disruption, or even aggressive pricing decisions made possible by Nvidia's dominant market position, could send shockwaves through the entire American AI industry simultaneously. China's more deliberately diversified approach, spreading chip production and infrastructure development across multiple domestic suppliers, including Huawei and others, at least theoretically reduces this specific kind of single point of failure risk, even though it currently comes bundled together with the real performance trade-offs and financing risks we already discussed regarding China's overall strategy. This single point of failure concern is not simply a theoretical worry either, since the broader technology industry has already witnessed how disruptive concentrated dependency on one dominant supplier can become when something genuinely does go wrong. Various industries have experienced real-world disruptions tied to over-reliance on a single critical supplier, whether through unexpected manufacturing accidents, sudden export restrictions, geopolitical conflicts affecting a key production region, or even straightforward pricing power that a dominant supplier can exercise once its customers have become sufficiently locked into that specific ecosystem with few realistic alternatives available. Nvidia's current dominance within AI infrastructure specifically means that any of these same categories of disruption, should they eventually materialize, could create outsized ripple effects across the entire American AI industry simultaneously, precisely because so many different companies are relying on essentially the same underlying hardware and software foundation for their most critical infrastructure needs. That concentrated dependency represents a genuine, structurally embedded vulnerability that America's overall AI strategy has not yet meaningfully addressed, even as individual companies within that ecosystem continue reaping substantial near-term performance benefits from remaining closely tied to Nvidia's continuously improving hardware and software platform. There is also a meaningful cost efficiency dimension worth understanding here, one that tends to favor China's approach in certain specific ways. Chinese data centers generally cost considerably less to build and operate compared to their American equivalents, driven by lower labor costs, cheaper component pricing, less expensive construction expenses, and substantial local government incentives specifically designed to attract this kind of large-scale infrastructure investment into particular regions. This cost advantage means that China's headline dollar figure may actually translate into more total computing capacity built per dollar spent compared to a directly equivalent amount of American infrastructure investment, even after accounting for the genuine performance gap currently separating Huawei's Ascend chips from Nvidia's most advanced hardware. Whether that raw cost efficiency advantage ultimately proves more strategically significant than America's continued lead in cutting-edge chip performance and software. Ecosystem maturity remains one of the most genuinely uncertain, actively debated questions among analysts and investors closely tracking this entire competitive landscape right now. Let's talk about demand projections for a moment, because they help explain why both countries are making such enormous, almost unprecedented infrastructure commitments simultaneously. According to comments reported by China Daily, demand for AI computing capacity within China alone is projected to increase by a staggering 5 or 100 times its current level by the year 2030. Whether or not that specific number proves perfectly accurate, it reflects a broadly shared expectation across both countries that AI computing demand is about to enter an entirely different order of magnitude compared to anything the technology industry has previously experienced, driven by increasingly sophisticated AI models, rapidly expanding real-world commercial applications, and growing adoption of AI tools across nearly every major industry simultaneously. Both China's state-directed build-out and America's private sector infrastructure race represent genuine attempts to get ahead of that anticipated demand curve. Rather than being caught flat-footed, once demand for AI computing capacity fully materializes at the scale both countries currently expect it to reach within just the next several years. It is worth pausing to appreciate just how genuinely unprecedented this simultaneous, enormous scale of infrastructure investment actually is when compared against previous major technology build-outs throughout history. The rollout of electricity across entire national grids took multiple decades to fully complete. The build-out of nationwide telephone networks similarly unfolded gradually across many years. The current AI infrastructure race, by contrast, is compressing an infrastructure build-out of comparable long-term economic significance into a dramatically shorter time frame, with both major world powers attempting to build out enormous new categories of critical infrastructure within a span of just a handful of years, rather than multiple decades. That extraordinary compression of timeline introduces its own unique risks for both countries, since building infrastructure this quickly at this scale leaves considerably less room for course correction. If initial assumptions about future demand, available financing, or underlying technology trajectories eventually prove significantly mistaken, compared to a more gradual multi-decade build-out that would naturally allow more opportunity to adjust strategy incrementally along the way, as circumstances inevitably continue to evolve. It is also worth examining the geopolitical dimension embedded directly inside this technology competition, because the two strategies are not developing in isolation from each other. China's push toward chip self-sufficiency has been directly and explicitly shaped by years of American export controls, specifically designed to limit Chinese access to the most advanced Nvidia hardware. In an interesting twist, some analysts have pointed out that these very restrictions may have inadvertently accelerated exactly the kind of domestic self-sufficiency effort now unfolding at such enormous national scale, since Chinese companies and government planners have had powerful incentive to invest aggressively in homegrown alternatives precisely because continued reliance on American technology was never guaranteed to remain available given the current geopolitical climate. Meanwhile, China has simultaneously moved to require government approval before Chinese AI companies can accept American capital investment, reflecting a broader, mutually reinforcing pattern of technological decoupling being pushed forward from both directions simultaneously by American export restrictions on one side and Chinese capital controls on the other. So who actually wins this competition? The honest answer is that it depends enormously on which specific dimension of victory you choose to measure, and the true outcome likely will not become fully clear for several more years yet. If raw, cutting edge, computational performance per chip is your primary measure of success, America's Nvidia-centered approach currently holds a clear, measurable advantage, backed by years of accumulated engineering expertise and a software ecosystem that will take considerable time for any competitor to fully replicate. If total coordinated infrastructure scale, national self-sufficiency, and long-term strategic resilience against external supply, disruption are your primary measures. Instead, China's centrally coordinated, domestically focused approach offers genuine structural advantages that America's more fragmented, market-driven approach simply cannot easily replicate, precisely because no single American company or government agency currently has the authority or coordination capacity to direct infrastructure development with the same top-down precision Beijing can exercise across its entire economy. There is also a meaningful timing dimension worth considering carefully before declaring either side a clear winner. America's private sector spending, while enormous in total dollar terms, is happening right now, actively being deployed and built out today, while China's plan unfolds gradually across a full 5-year window. That timing difference means America likely maintains a meaningful lead in actual deployed computing capacity over at least the next couple of years, even as China's coordinated infrastructure build-out gradually catches up and potentially overtakes America's total capacity later in the decade, assuming Beijing's ambitious plan proceeds roughly according to its currently announced schedule without major disruption or delay along the way. What makes this entire comparison genuinely fascinating from a broader strategic perspective is how clearly it illustrates two fundamentally different national theories about how best to win a critical, rapidly evolving technology race. America is betting that private capital, competitive market pressure, and continued access to the world's most advanced individual chip technology will ultimately produce a more innovative, more adaptable, and more globally competitive AI industry over the long run. China is betting that centralized coordination, guaranteed captive domestic demand, and genuine strategic self-sufficiency will ultimately prove more resilient and more somewhat lower raw chip performance, and taking on considerably more government debt in the process of building it all out. Neither theory is obviously correct in any absolute sense, and the eventual outcome will likely depend heavily on factors that remain genuinely difficult to predict today, including how quickly China can close its current chip performance gap, whether America's private sector spending proves sustainable over a genuinely multi-year time horizon without meaningful government coordination or support, and how broader geopolitical tensions between the two countries continue to evolve throughout the remainder of this critical decade, alongside factors like global energy prices, semiconductor equipment export policy, and whether either country experiences a significant domestic economic slowdown that forces a genuine reassessment of these enormous spending commitments. If this breakdown helped you understand the real strategic stakes behind these two competing national approaches to AI infrastructure, go ahead and hit that like button and subscribe if you want more deep dives covering exactly this kind of high-stakes global technology competition as it continues to unfold in real time. What do you think about all this? Does America's private sector, Nvidia-centered approach strike you as the smarter long-term bet given its current performance advantage? Or do you think China's centrally coordinated, self-sufficiency-focused strategy will test of a genuine supply chain disruption or economic downturn eventually arrives? Let me know your honest take in the comments, because this is exactly the kind of complex, high-stakes question where reasonable, well-informed people genuinely disagree, and I would love to hear which direction you personally lean on this one. It is also worth acknowledging that plenty of thoughtful analysts sit somewhere in between these two extreme positions entirely, arguing that the eventual outcome will likely involve elements of both approaches proving partially correct in different specific respects, rather than either strategy achieving a clean, total victory over the other. Technology competitions of this scale rarely resolve into simple, one-sided outcomes, and this particular race between American private capital and Chinese state coordination may well end up being remembered as a genuinely mixed result, with valuable lessons for both sides, regardless of which country ultimately ends up with more total deployed computing capacity by the time this decade finally comes to a close. Zooming out, this entire comparison offers a genuinely valuable window into how Differently, two of the world's largest, most technologically sophisticated economies are choosing to organize themselves around the exact same emerging technology opportunity. Neither approach is purely right or purely wrong. Each reflects a coherent, internally consistent strategic logic shaped by each country's own particular economic system, its own particular political structure, and its own particular assessment of where the greatest risks and greatest opportunities genuinely lie within this rapidly evolving competitive landscape. Watching how both of these enormous multi-year infrastructure bets actually play out over the coming several years may end up telling us more about the future balance of global economic and technological power than almost any other single ongoing story currently unfolding anywhere in the world today. Thanks for watching this entire breakdown. If you want to stay ahead of stories like this one, covering exactly where the global AI infrastructure race is heading next, make sure to like this video and subscribe to the channel, because there's a lot more unfolding in this space than most headlines ever fully capture. One final thought worth carrying with you after watching this. It is tempting to want a clean, definitive answer to a question like who actually wins this competition, but the honest reality is that both countries are running a genuinely live experiment right now. One, whose true results will only become fully visible several years from now, once we can look back and see which specific trade-offs each side made actually mattered most in practice. Raw chip performance, financing sustainability, supply chain resilience, and sheer coordinated scale are all pulling in somewhat different directions across these two competing strategies, and the eventual winner may well end up being determined not by any single one of those factors in isolation, but by how effectively each country manages to balance all of them simultaneously over a genuinely demanding multi-year competitive stretch that has really only just begun.